In this lesson, we are going to combine all the transformations that we've learned. So the translations, reflections, and stretches and compressions, everything in one. Now before we do that, let's just quickly refresh our memory and review the effects of each parameter. So the magnitude of A determines vertical stretch or compression factor. The magnitude of K determines the horizontal stretch or compression factor. D represents the horizontal translation. C represents the vertical translation. If A happens to be negative, it's a reflection with respect to the x-axis. And if K is negative, it's a reflection with respect to the y-axis. So the good news is most of these transformations you've already done from last year. The only thing that's new is K. So the horizontal stretch or compression is new, and the reflection with respect to the y-axis is new. Now that we have all these transformations, it's very important that we understand that we apply stretches and compressions first, then reflections, and lastly translations. In fact, you can switch the order of stretches, compressions, and reflections. It doesn't really matter as long as you save translations for the very end. Now, why do we save translations for the very end? Well, if you look at the equation, it makes sense to save translations for the very end. Let's look at the vertical stretch and vertical translation. So it makes sense to apply the vertical stretch first and then the vertical translation, because we're following bed mass, right? It's A times F of K times X minus D, and then we add by C. So it makes sense that we're applying the vertical stretch, and if there is a reflection with respect to the x-axis, you apply those transformations first, and then you apply the vertical translation. If you wanted to apply the vertical translation first, then the equation will be different. So it probably won't look like this unless we were trying to trick you, but here is how it would look. If that is how the equation looks, let's use square brackets because we had square earlier. If that's how the equation looked like, then you would apply the vertical translation first and then the vertical stretch. But that's not how the equation looks, so then I'm just going to erase it. I don't want to confuse anyone. So because that's not the case, then we follow this order. Okay, another thing I want to mention is that when you study this equation, remember that K is factored, okay? So if it's not factored, you have to factor out K. And we should really explain to ourselves why we want to factor. And I'm actually going to explain that logic in the next lesson when we study inverses, because it lines up perfectly. So I don't want to spoil it, but for today's lesson, just remember to factor K if it's not already factored. All right. So if we put everything together, this is super important. This is our mapping rule. Okay, that involves all four parameters, A, K, D, and C. So please remember this. If you haven't already, remember this by the end of the lesson. Okay, so K is factored. So hopefully you can establish that A is -3, K is equal to 2, D is equal to -4, C is equal to -1. So xy becomes 1/2 x minus 4 -3y plus 1. Now even though it doesn't ask me to do this, I generally like to state the transformations after I write the mapping rule because I want to make sense of everything. It makes sense that I'm multiplying x by half because horizontal compression by a factor of 2, and I shift 4 units to the left, so it makes sense to subtract by 4. It makes sense to multiply y by -3 because I'm vertically stretching by a factor of 3 and there's a reflection across the x-axis. And then finally I add by 1. Ooh, see, I caught my mistake. It didn't make sense. It's supposed to subtract by 1 because I'm supposed to shift 1 unit down. So if someone were to give me the mapping rule, I can give them the transformations. If someone gives me the mapping rule, I can give them the transformations. If someone gives me the transformations, I can give them the mapping rule. They go hand in hand. This mapping rule is really replacing all the words that you would have stated in the transformations. Okay, obviously this is, I feel this is better at least. Okay, so I need to know the original points and then I can transform them. So I am going to transform root x. So hopefully you didn't forget the key points for the square root function. It's hard to forget because you're just looking at perfect squares. Because otherwise you won't get very nice points to plot. Okay, so this is f of x. Alright, half x minus 4, so that's -4. Half minus 4 is going to be -3.5. 2 minus -2. That's going to be 4.5 minus 4, that's half. Okay, you can use decimals as long as they're exact. Okay, so this can be -1. -3 minus 1 is -4. -6 minus 1 is -7. And then -10. Okay, let me look at the numbers here. I'm going to scale it. I don't think I'm going to plot this point. I'm going to scale 1, 1. Yeah, let's do 1, 1. Okay. So -1, -4. Oops, -4, -1. Much better. Okay. -3.5, -4. And then -2, -7. -2, -7. It makes sense because it's vertically stretched by a factor of 3. All right. So hopefully your graph looks very similar to mine. Let me just make sure. So it used to look like that, but I'm reflecting x. Yep, it seems very reasonable. And I shifted 4 to the left, 1 down, so it makes sense the endpoint to be located at -4, -1. So yeah, a lot of good vibes when I'm checking my work. It looks correct. It's always a good idea to inspect your graph of your transform function. Okay, describe the set of transformations applied and determine the mapping rule. So, this one, I'll write the parameters down for you. A is 1, K is 1, D is 3, C is -1. So, horizontal translation, 3 units right. And then vertical translation, 1 unit down. What's the mapping rule? Well, this one's pretty straightforward. You take the x values and add by 3 because you're going 3 to the right. Take the y value, subtract by 1 because you're going 1 unit down. Okay, over here, I'm not going to write the parameters. Hopefully we can agree on the transformations. Vertical stretch by a factor of 2. Vertical translation, 4 units up. So the mapping rule, we have xy, and now it will be x and then 2y plus 4. Vertically stretched by a factor of 2, double those vertical distances, and then add by 4. All right, we're getting more and more. So horizontal compression by a factor of 2. Reflection with respect to the x-axis. Vertical translation vertical translation 3 units down. Let's try one more time here. Alright, so we got xy, it becomes half x and then negative y minus 3. Okay, what do we have here? Vertical compression by a factor of 2. Reflection with respect to x-axis. Reflection with respect to y-axis. And then vertical translation 3 units up. Personally, I value the mapping rule a lot more than all these words. But I'm hoping you realize the repetitive nature. You don't really need to do both. They mean the same thing. Alright, so we're looking at negative x, negative half y plus 3. It's negative half y. Alright, almost done here. So vertical stretch by a factor of 3. Horizontal compression by a factor of 2. Reflection with respect to y-axis. Horizontal translation 1 unit right. More importantly, the mapping rule. So we're looking at half. Oh, it's negative half because there's also reflection with respect to the x-axis. Oh, with respect to the y-axis. And we're adding by 1 because we're going 1 unit right. And then 3y. And that's it. All right. G, be careful. Sorry, F, be careful when you're working g of x. You have to factor the negative 2 here. So k is not factored. So it makes a big difference because a lot of students, they forget to factor k and then they state the wrong d value. Let's triple check, negative 2 and negative 1 plus 2. Make sure you factor correctly. A lot of students do it incorrect. All right, so this one is heavy. Vertical compression by a factor of 2. Horizontal compression by a factor of 2. Reflection with respect to x-axis. Reflection with respect to y-axis. We're going 1 unit to the right, so horizontal translation, 1 unit right, and vertical translation, 4 units up. Okay. Whew. Oh, I forgot the mapping rule. I was thinking about, well, I was pretty excited for this to finish, but I was also thinking about in grade 11 and in grade 12, you learn about transformations over and over and over again. But if you learn it properly the first time, then you're set. I don't want to spoil it, but we'll learn about exponential functions, and you're going to, after you learn about them, you transform them. After you learn about trigonometric functions, you transform them. In grade 12, you learn about polynomial functions, you transform them, and you transform trig functions again, and then you transform logarithmic functions. What I'm trying to say is, you're going to do this exact same thing at least 3 times or 4 times. So if you do this properly the first time, you are set. So this is negative half x, and then plus 1, negative half y, plus 4. Okay, all right, so I'm going to factor out k. So, let's see. That's going to be negative x minus 3, 2y plus 1. Okay, we're transforming 1 over x. So those are the points I need to grab. Those are points I'm going to manipulate. And that will allow me to get the points for my transform function. So negative 2 minus 3 is negative 1. And then negative 1 minus negative 2. Minus 4 minus 5. Okay, that will give me 2, negative 1, 0. Negative 2 plus 1. 2 plus 1 is 3, 1 plus 1 is 2. You know what? Let's see. So first things first, let's sketch in the asymptote. 3 left, 1 up. So it's now located at 3 left, 1 up. So x equals minus 3. And y equals 1. Sketching in the asymptotes is always a good idea because it gives you a guideline of the rest of the graph. Alright, negative 1, 0. Negative 2, negative 1. Ooh, that looks good. Negative 4, 3. And negative 5, 2. Perfect. Looks beautiful. Y equals fx. The scaling is 1, 1. It kind of got covered. Well, we can live with that. So that's it. We combined all of our transformations. So in the next lesson, we are going to walk away from transformations for a bit and talk about inverses of a function.